Alright, it wants us to identify the scale factor and explain. So remember the one without is the pre-image. And this is the image. So notice the image is larger. The pre-image has a horizontal side that measures 1 box. And the image has a side that measures 1, 2, 3 boxes. So to find the scale factor, you're going to say 1 times what number equals 3. And this will be your scale factor. So my scale factor is 3. Two. Again, remember your pre-image is the one that does not have the little tick marks. So this is my pre-image. And this one would be my image because it has the little tick marks here. So again, I need to find the scale factor. So I want to locate the horizontal line. That's 1, 2, 3, 4 boxes. And on the image, it's 1, 2 boxes. So I've got to find my scale factor, so I'm going to say 4 times what number equals 2. And whatever I multiply by is my scale factor. So my scale factor is going to have to be 1/2. Notice it's a fraction because the image is smaller than the pre-image. Next, I want to find the center of dilation. So I want to draw the lines to connect the corresponding points to determine the center of dilation. So I'm going to connect my points, my corresponding points. My corresponding points are A in the pre-image and A prime in the image. I want to draw a line to connect those points. Same thing with the next corresponding point. I want to connect B in my pre-image and in my image. Draw a line and connect the points. And then finally, my C point in my pre-image and my C prime in my image and connect the points. And so my center of dilation is always going to be the point where all the lines meet. Therefore, my center of dilation will have to be at 3, 1. Same thing, number 4. Says draw the lines connect to corresponding points. So my corresponding points in my pre-image is A. And in my image is A prime. So I want to draw a line connecting those points. Next, I want to do the same thing with B in my pre-image and B prime in my image and draw a line connecting those points. And then finally, C in my pre-image and C prime in my image and draw a line and connect those points. And my center dilation is always the point where the lines intersect. So that would be my center. So it would be at x coordinate 2, y coordinate 1. Number 5. I want to identify the transformations as a reflection. Remember, reflection is a flip. Rotation is a turn. Translation is a slide, and dilation makes the shape larger or smaller. So again, I want to locate my pre-image. The pre-image is the image without the tick marks. And my image is the one with the tick marks. So I notice to get from my pre-image to my image, I have performed a rotation. Because I have turned it. And I've also made it smaller, so that's a dilation. I want to describe the rotation. Notice I've rotated it 90 degrees. And it's gone counterclockwise. In my dilation, I have to describe it with the scale factor. If I notice my pre-image is larger than my image, on my pre-image, the horizontal shape is 1, 2, 3, 4. And on my image, it is 1 box and 2 halves, so that will give me 2. So my scale factor is going to be 4 times what number? Gives me 2, and whatever I multiply by is my scale factor. So my scale factor has to be 1/2. Same thing for number 6. I want to identify the transformations as a reflection, a flip, a rotation, a turn, a translation, a slide, or a dilation. Then describe. So I locate my pre-image. My pre-image is the one without the tick marks, and my image is the one with the tick marks. So I notice that it has been flipped because I have A and A. So that's going to be called a reflection. I also notice my image is larger, so that's going to be a dilation. So if I describe my reflection, I've got to say over what? So it's reflected over the y-axis. And I've also got to describe the scale factor. So if I get my scale factor, I measure a horizontal side. 1, 2, 3, 4. And I do the same thing for my image. 1, 2, 3, 4, 5, 6, 7, 8. So I need to find my scale factor. So the scale factor is what you multiply. So I've got to take my pre-image and multiply it by the scale factor. And it's going to give me 8. So my scale factor, 4 times 2 is 8. So my scale factor is going to be 2. Number 7, I want to identify the angles as vertical, alternate interior, or corresponding. And if I look at my angles, this is one angle, and this is the other angle. Notice that they're on different sides of my transversal. My transversal is always the line that matches. So that makes them alternate. And then they're on the interior of the parallel lines. They're inside the parallel lines, so they're called alternate interior. Number 8, again, identify the angles as vertical, alternate interior, or exterior. So I'm going to look at this angle here and this angle here. They're formed by intersecting lines and they're opposite angles. So that would give me vertical angles. Number 9, again, I want to identify my angles. So I'm looking at this angle with the green mark and this angle with the green mark. When I have parallel lines, I do it my transversal. Notice they're not alternate because they're both to the right of the transversal. They're both, one's exterior and one's exterior, so that would make them be corresponding angles. Number 10, similarity criterion. Identify the theorem that justifies why the triangles are similar. Explain your choice. So if I look at my values here, I notice 6 is measuring a side and 4 is measuring a side. 2 is measuring a side and 3 measures a side. So I know I have 2 sides. So I've got to check to make sure they're proportional. So 4 matches with 2 and 6 matches with 3. If I simplify the first fraction by a factor of 2, that gives me 2 over 1. If I simplify the second fraction by a factor of 3, that gives me 2 over 1. So those are sides. Notice I do not have a measurement on the third side, so side, side, side is out. The vertical angles are always congruent. We proved that. So our triangles are similar by side, angle, side. Identify the theorem that justifies why the triangles are similar. Explain your choice. Notice I have these arrows on my lines. Those arrows mean that the lines are parallel. And whenever you have parallel lines, then you're going to have corresponding angles or alternate interior. So here's the transversal, and I have the corresponding angles there. I also have another transversal, which would be here. So I'd have alternate interior or corresponding angles here. Therefore, the triangles are similar by the angle-angle theorem because I have 2 pairs of similar or of congruent angles. Number 13. Use the properties to determine the indicated angle measures. I'm going to use the triangle proportionality theorem. So I know my sides are proportional. So I'm going to say x and 2. So x is in my numerator, 2 is my denominator. And then on the other side of the triangle, 18 and 3. Then whenever I solve, I'm going to take and I'm going to cross multiply. So I'm going to multiply 3 times x is 3x. Multiply the other cross product, they're equal. 2 times 18 is 36. I use the division property of equality. Divide by 3 on both sides. So I know x equals 12. Last problem, use the properties of similar figures to determine, and again, this is the triangle proportionality theorem because you have one side parallel to another side. So I'm going to set up my proportions. I'm going to use the numbers on the left, 7 and 5. I'm going to use my numbers on the right, 5 and x. So I want to cross multiply to solve it. So let's say 7 times x is 7x. Find your other cross product. 5 times 5 is 25. So to solve for it, I use division property of equality. So I know that x is going to equal 3.57. Hope this helps, and we're going to take the test on Thursday. Let me know if you need any more help.